promise you that I will help you when you get stuck. So there we have it.
You can do this, Austin.
Okay, average speed. This is a physics problem here.
16 t squared. Is that like an actual constant? Because it's always 16.
Yeah, it's acceleration due to gravity comes into play here. So yeah.
Okay.
It's 16 if you're working in feet per second, and if you're working in meters per second, you'll see 9.8.
Yeah.
That doesn't make any sense.
I was just wondering if that was like
9.8 meters and 16 feet or not.
Not even close.
Yeah.
It's like 27 feet, isn't it? 30, like 31 feet. I was scuba diving with Canadians.
So can I just substitute
Oh, you know,
6 in
it's
for
really
T?
good places, Rice.
Yes, and if you do that, what will you know?
It's average speed during the first 6 seconds of fall.
No, if you put, this is a function that takes a time and spits out feet, a distance. So.
Oh, and then we have to calculate time and distance into feet.
So, the average speed is you have a distance function. Speed is what in relation to distance?
Oh, we did this in
The
physics
Physics,
yesterday.
yes. What?
No, it's like delta speed over delta time.
What are the units
is
for speed?
feet per second.
Feet over seconds,
Yeah.
right? Okay. So we want average speed, so we're probably going to need to divide some quantity of feet by some quantity of seconds to get a speed, right?
It's like delta T for delta X.
Exactly. Delta, it's going to be delta D for distance, or H for height, over delta T, which is time, and that's going to give you your average.
Guys, it's like in terms of 6.
576.
It's 4 times 4 times 6 times x.
Okay, so that
576.
number right there, 576,
I got there, but it
represents
took me
what?
longer. So, yeah.
What does that
Alright,
represent?
delta T.
Not well. Yes, because we're assuming like that we're holding it at time 0, so its distance traveled is 0, and then we drop it, and 6 seconds later it's gone 576 feet. So yes, it has delta. That's actually delta H, the change in its height. And is it positive or negative? Delta H. That's obviously a positive number, but has our height increased or decreased? If we're standing on a building and we drop this thing, yes, so
It's negative delta H?
You can't have a negative distance.
Yes, you can. Remember we were doing
No,
that
you can
thing
have
with, like,
negative
when you-
velocity. You can't have
yeah.
negative
yeah.
distance.
No, you're going to keep it positive. It's fine. So what I want you to do actually is look at this and know in general that the average rate of change, which is what we're talking about, so write this down, average rate of change on, and then bracket a comma b. So in general, for any function, its average rate of change is going to be f of b minus f of a all over b minus a.
Oh, yes.
Okay, so what this is doing is giving you kind of a physical context for the slope of what kind of line? Does that?
Straight line?
Yes. It has a particular name that when we draw a line like that.
Linear.
A linear line?
Vertical?
Linear.
Are we being silly now?
Yes.
Vertical
It starts with an
line?
S, and it's a term,
Secant.
a secant line, right? So we have our curve, we have our points at A and B, we connect them with a line, calculate its slope. That tells us the average rate at which whatever function, whatever our curve has changed over that time interval. So in particular here, our curve, our function is not just a general function, it's a distance function. So if we do this thing over a particular interval, we will get the average rate of change of distance. What is the real world interpretation of average rate of change of distance? Yes, speed. So average rate of change of distance is the same as average speed. So we're doing this sort of thing on this context. So now, what is A and our B in
Can we just like randomly assign A 6 and B a 16? Because those are the only numbers we have.
No.
Okay.
We start off holding the watermelon. What time? When we're just about to let it go. That's time what? T equals 0. And then we want to see how fast it's traveling over the next 6 seconds. So A would be 0 and B would be 6. Okay. So we have the interval 0 to 6. Yes. So that
Alright.
tells you something now about the denominator of our speed.
Which is 6.
Uh-huh.
This equals 6. Yay.
Okay, and how about our numerator?
That is 0, f of 0 minus f of 6.
F is the same as y here, so it's actually f of 6 minus f of 0. And you just found f of 6, didn't you?
F of 6 is, so that's 576?
Right. And what f of 0?
0.
Right.
So it's just 576 divided by 6.
That's right.
Why are there teeth marks all over my glasses?
I'm only 5'10". I was not talking to Cooper.
Why did you let
Okay,
Cooper
I'm
bite
gonna
my
give up.
glasses?
What is that?
96.
How'd you know
Okay.
that?
Because I do.
And what are your units here?
Feet? I mean, per second. Feet per second.
Feet per second, yes. And you should see that 576 is feet, the 6 is seconds, so we just get feet per second. Alright, excellent. Stop the recording.
That was weird. It started as a sneeze and ended in a yawn.
As soon as the mouth is on.
The mouse is being a little